Hello guys, welcome once more to another video on our YouTube channel. So in this video we are going to look at how to integrate a hyperbolic function. But before doing that, we begin with expressing 8 cosh x plus ln 4 in this form. Then we use the idea of expressing it in this form to integrate it. So first of all, I want us to recall that the cosh of y is equal to half into e to the y plus e to the negative y. So to get 8 the cosh of x plus ln 4, I just need to replace the y with x plus ln 4. If I replace y with x plus ln 4, this is what we get. We get that 8 cosh of x plus ln 4. The 8 is outside. By the definition, we need to indicate a half. Here is a half. In the place of y, we replace it with x plus ln 4. The negative sign will affect the x and will affect the ln 4, and we are going to get 8 times half is 4. Now from indices, e to the x plus ln 4 is e to the x times e to the ln 4. Now this negative sign will affect x and will affect the ln 4, so we can also separate it this way. Now we know that e to the ln 4 is 4, okay, and e to the negative ln 4, we can send the negative 1 to 4 and it's going to be in the power of 4, and we are going to get here e to the ln of 4 to the negative 1. But 4 to the negative 1 is 1 on 4, and we know that e to the ln 1 on 4 is 1 on 4. Now we multiply all through by 4 and we get 4 times 4 16, and 4 times 1 on 4 is 1. If we compare with the form we are required to put our answer in, then we can deduce that a is 16 and b is 1. Now the second part is asking us to use the previous information, or we use another method, that's why they say hence or otherwise, and show that the integral from 0 to ln 2 of this function is equal to this. So first of all, I'm going to replace my 8 cosh x plus, I'm using the hence, okay, I'm going to use the information from the previous question. So I'm going to replace 8 cosh x plus ln 4 with its identity, which is 16 e to the x plus e to the negative x. Now to remove this e to the negative x from here, okay, because it is bizarre, I better remove it from here so that I have just powers of I just get the powers of e to be positive. So I need to multiply the numerator and the denominator by e to the power x. When I multiply the numerator, I'm going to get e to the power x. When I multiply the denominator, I will need to multiply the two terms. When I multiply e to the x with e to the x, it will give me e to the x all squared. When I multiply e to the x with e to the negative x, I'm going to have e to the 0 because I will need to add the powers, and e to the 0 is 1. Now I can identify 16 e to the x all squared as 4 e to the x all that squared, okay, because when we square 4 we get 16, when we square e to the x we get e to the x squared. Okay, now we are going to first of all use a u substitution. Since when we differentiate e to the x, we still get e to the x, it therefore means that that is actually my u substitution. If I let u to be e to the x, okay, when I differentiate, du will give me e to the x dx. Okay, that is that because du by dx will give me e to the x, so du will give me e to the x dx, and e to the x dx happenly is actually the numerator of my integrand. All right, so I'm just going to replace it with du. Now I'm going to change my limit. When x is 0, my u is e to the 0, which is 1, and when x is ln 2, my u is e to the ln 2, which is 2. Now from there we can now change the limits, and we have the integral from 1 to 2. Those are the new limits of u. In the place of e to the x dx, we replace it with du. In the place of e to the x, we replace it with u. Then we need to square, then we need to add 1. From here I now need to use another substitution, a trigonometry substitution. So I can take 4u to be equal to tan theta. When I differentiate both sides, I get 4 du to be equal to sec squared theta d theta. When I differentiate 4u, the 4 is a constant, so I just need to differentiate u to get du. When I differentiate tan theta, I get sec squared theta d theta. Now we need to change the limits. When u is equal to 1, tan theta is 4, so theta will be tan inverse of 4. And when u is equal to 2, tan theta is 8, and theta will be tan inverse of 8. So it therefore means that we get in the place of du, we replace it with sec squared theta divided by 4. Okay, this is a 1 on 4 outside, and then now in the place of the du, we are replacing it with 1/4 times sec squared theta. Now going to the denominator, we need to replace 4u with tan theta, but we need to square, then we add 1. All right, now we need to put the values of the new limit. Theta is from tan inverse of 4 to tan inverse of 8. Now tan squared theta plus 1 is sec squared theta, so it cancels with the sec squared theta in the numerator, and we are going to be integrating d theta Okay, and once we integrate the theta, we get theta. When we fit the limits, we need to take tan inverse of 8 minus tan inverse of 4. But the definition of tan inverse of A minus tan inverse of B is tan inverse of A minus B divided by 1 plus AB. So A is 8 and B is 4. So I need to take tan inverse of 8 minus 4 divided by 1 plus 8 times 4. 8 times 4 is 32 plus 1 is 33. 8 minus 4 is 4. So at the end of the day, the proof comes out perfectly. If you like the video, make sure you actually like the video. Okay, if you love the video, click the like button, share the video with your friends, subscribe, and also comment. Thank you for watching, and see you in the next video.